Alright, let's get started. Here goes nothing. So, a little rememoration of what was the last things we have been doing. We have been writing the add with carry and the bitwise operator, the AND bitwise operator, and now we are going to be working on the next opcode. So I started to create a board in GitHub project to get some organization of what is coming next. So you know that we have this tracker at the start of the stream, but this is like a little more formal with to like be focused on what needs to be done. So I have created 2 tasks that I would like to do before moving on. One is migrating the tests that we have that are all in a single file to split it in different classes. So the first task is creating a base class for that task or operation, and the next one would be moving the existing code to new class to new script. So let's do that. So first, the task is about so this is the first one to do. Create base script for a test group and test. So I will create new scripts that will inherit node. I will name this one test or base test. It is suggested to not use base as name of a class, but because I am not going to use class name, I don't care really. So I will just go ahead and make an empty script that extends node. My test node, the only thing that will have is a function that is called test and asserts. This method is meant to be overridden. That's all with the base test and the test group. So the test group is just like a redirector or something like that. So what I am going to do with it is func test like the other one, but what I am going to do is iterate over the children for test script in get children if test child is, and we confirm it is of the type of the base, test script to test. So what I am doing wrong? Effective type after is. So we cannot use this. Should I use extend? No, I should not. I make var test base equals reload and this, and it's test base. Does it work now? No. So it's not a type. But then I will just do this. If test like this. If test in test script and run it, and we don't care. So what we are going to do in our test NES is exactly that. Before or after all these functions, we are going to run test in all the children. So we are going to assume this is a test group, and we are going to call test in the test group. We could even assert that there is a function, but we don't care about that, right? So let's make a folder for the NES test. And I will make a new script for the LDA. And I am going to inherit the base test. We'll open it, create my test function, and I will move my LDA functions from this file to this file. This one is not here anymore. This one is not here anymore. And I will take my LDA functions from here, and I cut, and I will paste them in my new test script. So I have the script, and now I have to add it to my test scene. So I can add a new node, so I can make it a CPU test, and I will add another node and make it the LDA test. So if everything works, now this script should be, this function should iterate the groups. Alright, I have to assign the test group to this node, and it will iterate the group, and then the group will iterate the individual test, and it will all execute. So let's make a breakpoint and let's see if it works as I expect. So iterate the first test group. I advance. I am at position 0, and this is the array that I am iterating. The only children is indeed my CPU test group. So I enter, and I can start testing. Now it will, this is a group, it will get its own children. The only children is indeed the LDA test. So it executes, and it will try to start executing the test, and all of them pass it. So yay! We continue running, and we passed all the tests. So awesome. So looks like we already have our base classes ready to go. So I think I will make a commit, git status, git add for part, what changed it? Yes, remove this, remove all the functions, and create the added nodes to this. And we have to add new scripts as well. Git add add-ons and everything basically. Git status, Everything new is here. Git commit create base script for unit test and test groups. Closest one. What did I do wrong? Did not match any file because I forgot passing the message argument. Git push, and if everything is correct, this should be automatically be passed to done. Yep, it did. So move the existing unit test to different scripts. That should be quite fast. We have already done LDA, so we have to make new scripts. Why are you not clicking? Okay, there we go. So next is STA, and let's make it a template. We extend it base test. I will copy it from here. Okay. So I will create the other scripts and we'll just copy and paste this for all the scripts and then get started to add in the contents. So I created STA script. Next is ABC. New script and new script tax, and let's name it tax stay, and we test both together. And I think these two will stay in here. So let's go in alphabetical order, I guess. Save this. LDA is done. This is done. Tax save. Okay, awesome. So next one is STA. So, this is the content of my STA. Will cut. Delete the header. Go to my STA script and paste the function call. And then we'll go back to my test NES and we'll look for the STA functions from here to here. This is the first one. Cut and paste them, and it should be already done. So now it is much more easier to find the test for what instruction, and also it's easier to copy a group or some base code from one instruction in particular and paste it in another script that we are going to make. To test NES, next is add with carry, and add with carry uses all of these. And test NES, and let's select all the add with carry functions, all of this, cut and paste it here. I'm going fast because I don't want to lose time. And what is next. With carry no longer exists. The AND operator is next. AND operator uses all these tests. Paste it in here. Let's find the actual test. From this to this. It's pretty convenient to have it folded, but it's much more convenient to have it categorized in different scripts. Done with AND. Let's go to tags and date. Take I guess it's all of this. I will put all of this and paste it here. And this shoe will go back to my NES test. So this one tests the overflow particularly. So this is in theory already tested in IncX. Please, do we have IncX intake? No, we never created test cases for that. So I will choose pass for now. Because we have the IncX instruction, we have not created test for IncX or IncY. We only have transfer X and Y. Well, I wanted to get rid of this part fast because it's boring. So let's do this. Let's continue with the next task, and if we have some time after that, we will create the missing test for the instructions that we have in our CPU. So we have our NES view, and we have ABC, which has test, AND has test, LDA has test, SDA has test, SDX and XDY are the same as SDA, it just uses a different register, right? So it's the same function taking care of all of them. Same for transfer, the same function is used for transfer. And increase X and increase Y uses the same function for increment of the register. So yes, IncX and INC1E are the only ones that are not being tested right now. So confirm that. So does this move the existing unit test to a different script? So on. So let's just try it out to make sure I did not mess up anything, and everything still passes, which is great. But only LDA is running. What is going on? Oh, I see what is going on. So I did not add the test to this list. So let's create a couple of nodes for the missing ones, and we have to test ABC and LDA No, LDA already exists, sorry. SDA. And tax type. And this one still doesn't exist. So ABC and LDA, I will move it down here to have the same ordering. SDA, tax and type, save and run again, and now everything passed. So this is an inconvenience that I did not consider, but I will choose to ignore it, because otherwise it will become a nightmare. So let's move on. Let's commit this. Sorry. Git status, git add, and what did change? So we deleted all of this. That's correct. I think I am missing something. Let me see. Oh no, it's here. It was still here. It's true. So never mind this. Let's do this. Let's create a template for the scripts. So first we'll commit this. So all of this is new. Git commit move ADC and SDA tax and type and test to individual script. Let's push it. Oh right, and I forgot to indicate it closes the issue, so I will have to close it manually. Let's open it here and let's set the status to close. Okay, unit test for ASL is the next task. Let's convert it to an issue, and we have our issue, and we can now start creating our first test with this new approach. And first I will create a template file. So let's search documentation for script templates. Creating a script template. So by default you have these templates that are built in the engine, but you can also create your own custom templates by locating them in a script templates folder. So I can come here and create a script templates folder, and I can make a new script here. Test. Actually, actually you have to identify a parent class. So I would need to make it a child of node. So the way you specify the parent class is creating a folder and put it inside. So by doing that, when you create a new script, Let's say you want to create a new script over here. New script. Because object is selected, it's nothing, but you can see that in Node I can select my test script. So this way I can copy the text from this and paste it in my template. Make it a path function here, and then now I can create a new script in this folder. I can select the test template and I can name it, what was the name of the next instruction? ASL. ASL. Not focused. And the ASL was created with my template, so it has the function preloaded and has the extend, prefilled, and all of that. And in fact, we can even improve that, because we can take in example LDA and take this part and come to our template script and paste it and remove the opcode and remove the instruction, and I think we can use put the file name in here. Let's see how to do that. In our documentation, so it says, let's find the part. So this one says base, so it's base and class. Class is only for C#. Base is the base for the script. So I think class will use the file name in GdScript. So let's confirm that, save that, and let's recreate this file. So I will delete it and create it again. ASL using test, and it failed. After expression found identifier. So right, because I think I have to remove the brackets. That was dumb, sorry. Class, and let's try again. So it created ASL, but it made it uppercase, but that is still easy to fix. Delete it again and try it. New script, ASL, create, and indeed it created the file. And actually we can even go further, but I think we don't want to, because I could also create the function and put pass, but then I would have to do a lot of it's probably worth, because I will have to set the opcode, but I was going to do it anyway. So yes, I think I will do it. So let's continue editing this. So turns out we also don't want to set payload, because this is the description of the name of the class, right? So we will just have it like that, and we are going to copy all of this, paste it here, and error setup, right, boom, go to the end, colon, next line, pass, next line, and now all the functions are defined and ready to get filled in our new script. So last time, hopefully, let's delete this one, and let me check. Do we have something for lowercase? No. Okay. In this case, okay, okay, there is nothing for case. So it's a shame, but it's fine, I guess. So new script, new test, ASL, and this is as easy as selecting everything and going to edit, convert case, lowercase, and now it's in lowercase. So let's continue fixing this. First thing to do is see what is actually ASL, and ASL is arithmetic shift left. So let's take this and we'll paste it in here. Put some lowercase, sorry, the underscore, make it lowercase with shift F5, which is the shortcut that you can see here. Shift F5. I can now copy this name of the function and put it in all of the other functions, and also on all of these functions. I am holding Alt while clicking to put more and more carets, and I paste, and now all the functions exist in the required sheet. Oh, missed one. So the next would be setting the opcodes. So turns out there are not so much opcodes. So you have the accumulator, 0 page X, absolute, and absolute X. So we never use um, explicit, immediate. So let's rename these to accumulator. Is with choosy? Yes, it's like this. Let's rename this. And let's see, what else do we have? 0 page and 0 page X. Like these two. An absolute and absolute X. And the rest do not exist at all. So this is the ones we want. We have 0 page X, absolute X, and this one does not exist. Okay, seems about right. And now we can fill the opcodes. So let's see, the accumulator is where is my music? There we go. The accumulator is OA. And OA. The 0 page is 06. Absolute, 0 page X is 16. Absolute is 08. And absolute X is 1E. So yeah, we have the header for our test. So let's see what this shift operation does. This operation shifts all the bits of the accumulator or memory. The contents of 1 byte of one shift to the left. Bit 0 is set to 0 and bit 7 is placed in the carry flag. So the effect of this operation is to multiply the memory of the content by 2, ignoring 2's complement considerations. Setting the carry if the result will not fit in 8 bits. So let's see what this affects the register, affects seed, affects 0, affects the carry, and affects negative. So I think we can make it all in one test. So we can test all of these with only one case. So let's copy for a moment the contents of LDA. Let's enable distraction free mode. I will copy the contents of this and go to the shift to the arithmetic shift left, and I only want one case. So I want to load a certain number. Actually, we are going to need a couple of cases to test different things. So let's try the binary 1, 2, 3, 4, 5, 6, 7, 8, and then end. Sorry, and the instruction OXOA, and that would be all. So I will copy this and paste it 3 times, and let's test different cases. And we want to test the 0 flag, the negative flag, and the carry flag. So the first case is I want to shift this value, and this one will be 0 because when it shifts to the left, the 1 is going away, and this one will be a 0. This will carry the 1 and will not be negative because it will be a full 0. And I want to check this one. This one will not carry, will not be 0, but will be negative. And I think that is all the cases that I want to test. I could test shifting 0, but makes like no sense at all. And the other thing we want to test is what is the actual value, the resulting value. In this case, the value will be 1000. In this case, it will be just 0 for the register, and that's about it. I think we can move on. So how does 0 page works with this one? So 0 page would take I assume it will shift the value of the accumulator by whatever number is stored in this memory address. And also I assume accumulator will just shift the accumulator by 1 always. It's a weird case because it only takes 1 byte, and that is only the opcode and nothing else. So I am assuming it will shift the accumulator by 1. This one takes 2 bytes. And what I am wondering is, it shifts the accumulator for whatever is stored, or it shifts whatever is stored by one and stores it in the accumulator. So what we can do to clarify that is see in the tutorial what did this person who made the tutorial do for ASL. So there is this code that is the result of the end of this chapter. So we can find the ASL function. So we have ASL accumulator and ASL addressing mode. In the case of the addressing mode, it will take the data, will get the address, get the data, and shift the data. Okay, it is setting the flags. It's setting the carry flag first, and it is shifting the value and writing the value in the same address. Okay, so it doesn't use the accumulator at all in this case. It is shifting the content of the memory by one and storing it again. Okay, that works. So what I want to do is load the value, transfer it to my memory, I want to how was transfer? Oh, it was STA. So let's see, the instruction for STA was STA immediate we don't have immediate. Right, we have to, it stores whatever is on the accumulator, so we load in the accumulator and then store it. We actually don't even need that. We can just set the memory mem write. So we can say memory mem write, and we are going to store it in the first argument. Sorry, this was not the function, it was this function. And it was not even this script. Oh, this. I need to pay more attention now. But I had the same problem anyway in the other cases. So I can set the memory in 0 to this value, in 1 to this other value, and I am messing up again. So I have to make it in 0 page function. Sorry about that. So this doesn't exist. This doesn't exist. And we only need 2 values. So we don't need to load. We just need to shift with this code the 0 address and the 1 address, and we don't need anything of this. So what we want to assert is that memory mem read of 0, 0. Oh, sorry, this is 0, 1 equals to this. And in this one, reading the memory 0, 0 equals to 0. So done for 0 page. Let's copy the name of the function and paste it here. Copy the name of the function and paste it here. And 0 page X next. So I will copy the entire function. That's correct. Paste it here. And now we want to do a couple of things. First, I want to load a value of, let's say, 5. So how was LDA? LDA was 0x0004. 0x0004 was load. I want to load, let's say, a 5. 0x5. Sorry, 05. And then we want to use the command, which is now 16 instead of 6, and pass a memory which will a value that will be 0 and 1 again. But now this will add the 5 to this value, so this is going to be 5 and this is going to be 6, and we are going to test 5 and we are going to test 6. And that should be all for 0 page. Now let's go to absolute, and this is more or less the same, except it will use a 2-byte address. So we are going to set, I don't know, 4005 and 4006, and we are going to load 5. Alright, I forgot part of the instruction, which was transfer the accumulator to the X register. So tax day, let's see, so transfer to X is OXAA. So we need to do that in here. And this one does not need transferring because we are not using the X register, but the next one will. So let's move on. So this one I want to. This is absolute, so we actually don't need to load anything or transfer anything. We should set the memory and try to shift the value. Actually, after each step we have to rewrite the initial value, otherwise it will try to do the operation in the same memory location and will file the second one. So I got almost bitten by the snake. But it was using one address per test in here. So this is fine. Sorry about that. How about this? Is it also fine? Yes, it's fine. This is using. This is still not using anything. So this one will shift with OE. and then the memory address. So this is little endianness. So the first one is 0x0, sorry, 0x05, and then 0x40. This is a 6 instead of a 5. Well, we can do 0 and 1. Let's keep it for now. So it will shift the value of this memory and then close. Right, this is this was a carryover from the previous one, and we want to test these memory locations. I am not sure how much sense this makes to a viewer, to be honest, because I am going really fast and I don't know how useful it is. Let's make it lowercase. No, it should not make everything lowercase. Forget it. Yes. And the function instructions, this, and this, lowercase, and all of these make it lowercase. Right, this one as well. And this. This is okay. This looks okay up until now. And this one. And we are going to test the same locations, but we are going to change the instruction. We're going to make the 1E instruction, and we also want to store a 5 in the X register, so I will take that from here. This is load 5 and transfer to X register. And we are going to paste it here before doing the other command. And instead of 45, I want to load 40, 0, and 41. So that way it will load a 4000 and add 5 to this, and it should get into the same memory addresses and perform the operations that we want it to perform. This instruction is named like this, and in theory the test instruction is all done. Famous last word. So we cannot test it without implementing it, but I will commit it. So I will create the new node for it, name it ASL, and it is located before LDA. We will assign the script and save. And if I try to run now, it should fail because the instruction is not known, right? So it's trying to read an instruction and it doesn't know it. It say the instruction was 10. That means in hex that is OA, and that is exactly my first ASL instruction, OA. So this is as far as it has made. It is trying to run my test and failing because of course it is not implemented. So this completes the part of creating the test. Status git add everything. We have new test, modification in the scene, and the new template. So the template folder is kind of annoying because sometimes these script templates do not compile. So one thing you can do is come to this folder and add an empty file, call it .gdignore. And after that, the folder has disappeared from the editor and you cannot see or edit it anymore from here. So now if I want to edit my script, I have to do it from an external editor. Let's say Visual Studio Code, or using file open to find it. So if I use file open, I can. Oh, this is okay. That's interesting. It doesn't look in. It is looking in the file system and not in the project. It's strange that it doesn't even see my project folder in here. Maybe it's ignored on purpose. That's weird. Anyway, let's commit this. It's status. We have to add the gdignore. Git commit. Create test case for ASL opcode. Closes. And what is this? Actually, I will add this in a new line. Closes. And I think it was 3. Yes, it was 3. And now 3 should go directly right into done. And I will create a new issue for the ASL opcode. Oh right, I didn't push it. Push to main. And this should automatically be gone away to done. There we go. And now we want to create our arithmetic. Oh, I forgot that. I forgot to put the name of the function. That was dumb. So this was... I thought I did that. I should have... Oh, sorry, this is my test. Brain fart. Sorry. Yes, arithmetic shift left. So... Bam. So I will want to go to my NES CPU and create the function. Let's create this one after and before LDA. ASL func arithmetic shift left, and let's say this doesn't take a register, it should take an addressing mode. The same as the guy in the tutorial, we are going to make one function for the addressing mode and another for the accumulator. So this one, we will take the we will copy this. We get the address using the addressing mode. We get the value from the addressing mode, and now we do the operations, and then we update carry flag using, I suppose this was the, yes, this was the full value. So then they're not full value, right? So bar shifted equals value, and then one, yes, we want to shift it only one, sorry about that. So this one is shifted, and now we want to memory mem write, and we want to write in our address the value of shifted, but only the first 8 bytes. So it's not double and. So what I am doing wrong? Okay, this is not a register value. This is the new value. So let's do bar result, and this is an integer, and this is an integer, and let's put this into result, and let's put result in here, and negative and seed flags will use result to update itself. So in theory, this is all for ASL for memory addressing mode, and I will copy it and make another version for the accumulator. And this one doesn't need anything. I could name it register, and I take the register instead. So I don't need address. I should take the value from the register. I shift it, make the result, set the result in the register, and then update the flag. In theory, we are almost ready for go. The only thing that is missing is registering our instruction. So we are going to register ASL. Let's copy just one line from here and paste it in here. Let's empty this. Let's fill some values. This is arithmetic. Oh, it doesn't autocomplete, so we have to look for it. Arithmetic, shift left. And this one only needs the addressing mode. And I will copy and paste. And arithmetic, shift left, register. And this one will take the register A. I will create a couple of copies. and as before, complete with our opcodes. So for the accumulator, we are going to use OA. For 0 page, we use 06, 16, OE, 1E, and this is 0 page, 0 page X, absolute, and absolute X. So who wants to give it a try and see if everything blows up? Okay. Unknown instruction with code 64. So let's take our calculator. Programmer, and 64 is the hex 40. And let's see where is 40. Okay, it is trying to use 40 as an instruction, and I think I already know why. So it is trying to use this 40 as an instruction, but this 40 was meant to be an address, part of the address, and that is because we have set the instructions, set the callback, setting the addressing mode and everything, but we did not fill the bytes and the cycles columns. I have forgotten about that. So the first one is 1 byte, 2 bytes, 2 bytes, 3 bytes, and 3 bytes. This is 2 cycles, 5 cycles, 6 cycles, another 6, 7 cycles, and that should be about it. Let's try to run it again. This is why we have tests. And now it passed. I am very amazed. It worked like a charm. The unit test, I mean, worked like a charm. Besides, they wasn't tested before. So, git status, only one change. Git add import. Yes, we registered stuff. We implemented 2 functions, and that was all. Git commit, message, implement ASL opcode. Closes, I think it was 4. Was it 4? Indeed it is 4. And git push. And this thing should be sent to done. So next task, the BBC unit test and code. Let's attach it here. Yeah. Here we go. Next is BCC. Branch if carry clear. So we have not done any branching yet. So this will be fun, famous last word. let's create a test script. New script. So VCC and VCS are very similar. So I think we can do both together. And also the good thing about them is that they both does not take does not take arguments, right? So they don't need addressing mode. They should take a literal. So it's an immediate read of the values. So what we are going to do is this is says relative, but the way you read the value is immediate. So I created VCC and now I can populate this information. Oops. Yeah, let's just do this, move to the end, and one click on each of these lines. And this is branch if carry clear. Branch if carry clear. So branching is, oh, I messed it up. Let's do this, I guess. Yes. Branch if carry clear. There we go. And this should be quite straightforward. What branch does is basically a function call or a if condition, and what it allows you is to change what is the code that you are executing. And you usually use it for an if condition, so you say if the condition what did happen in this case, the carry flag was on and now is off. Sorry, the carry flag is off. It will move the program counter to this new address. Sorry, to the current address plus this value, which I assume is signet value. So I will confirm that with this relative. So I assume this is signet. Used by branch instruction, blah blah blah, which contains a signet a bit relative to the offset. So yes, so it is minus 128 or plus 127, which is added to the program counter if the condition is true. As the program counter itself is incremented during instruction execution by 2, the effective address range for the target instruction must be, yes, it is of course a range that you can move around, because you need more than 1 byte in that case, right? So turns out we only need immediate for this one, so we don't need any other than immediate. It's not even called immediate, it is called relative. So let's rename it. lowercase b, and the opcode is 90. And the same for BCS. So maybe I will choose to both on the same test. This is if carry clear. And this is if carry set. And it's PO instead of 90. Oops. And pass. So I am. What is wrong here? Branch is carry clear. P60. Yes, P60, not PCS. So we want to make some tests in here. So we are making a program. Let's take our LDA. Notice it doesn't change any value at all. So this is what we are going to use. We are going to make a new function, and we are going to confirm that the register X, let's say, is equals to 0, and I will explain you after why is that. So what I want to do now is first making sure that the carry branch is clear, and because it's clear by default, I can just run it. And our first instruction will be jump if the carry is clear, and then some stuff here, some unknown relative value, some stuff in here, and then the rest of the instruction that will be just stop doing it stuff, right? So this is what we are going to do. What we are going to do is load some data. LDA, I think it was 0x9A, was it? A9, sorry. A9, I am going to load a 5. And transfer it to X. And that was, I think, AA. Yes, AA. OXAA. So that means we want to move the program counter from these instructions 1, 2, 3, 4 4 4 slots, like an offset of 4. I am yet not sure if this counts from this instruction or counts from the end of the instruction, and sadly we don't have the test cases for this example in the tutorial. So we will have to see what happens, right? So maybe we load a different value, let's say a 3, and make the jump and make sure it is still a 3, right? Because if it comes to this instruction, it will transfer um, it it will transfer the right. So we always want to transfer. So what we want to jump is this part. So we only jump like we jump 2 or 3. We are going to find out, I guess. And what we can do is see what it does in the example code. Like is the bytes of the addressing mode considered or not? I assuming not. So it is a jump from the end of the uh, of the bytecodes. So this is the example, and let's see BCC. What is this? So self branch and some condition, right? So we can search for branch function, and we have a condition. If the condition happens, it will read the program counter and it adds 1 and then jump. Okay, so it is reading the next value, and then it is adding 1 because of it is reading the um, okay, jump address. So why jump address itself? Okay, now I get it. It's not self, it's self program counter. That is what is happening. So it's adding 1 with wrapping and then adding again the jump value. So yes, and that is because program counter has not changed um, until the execution of the opcode has finished. So yes, it is basically jump plus 1, right? And the wrapping is signed. Mhm, mhm. So I wonder why is treating it as unsigned 16 if it is supposed to be a signed jump. I think that is wrong. I could ask this guy about it. We'll do it later, I guess, off stream. But yes, so the offset is indeed um, from the end of the instruction. So this is an ID. Uh, it's from here. we want to jump these two, and we want to end on this one. So, where is my music again? There we go. Let's copy this and paste it, and we have to do basically the same, except we want to make the carry set before calling this function. And to set that variable, we are going to write in a binary like this: 1 2 3 4 5 6 7 8, and we are going to do the shift left operation in the accumulator, which was OA. And if we do that, the X register, so if we put a 1 in here, the X register should be like this, right? It will move the first one to this place and will set the carry flag, and will make the jump, and it will be a 3 and not an OX5. So this should be all for the test. So let's give it a try. So we cannot test them, of course, so we are going to assume they are correct. So I will rename this to PCC PCS, and I am going to create a node, call it PCC PCS, put it after ASL and assign the script. And this should fail because of the not known instruction, but we can at least see that the instruction that is trying to execute is 144 and should be one of the instructions we are testing. So let's search my calculator. And see that 144 is indeed 90, and 90 is this function that indeed is meant to make the jump of two values and goes right to transfer. So in theory this is working, famous last word, and we will commit it. Oops, I accidentally closed that. Let's open it from here. Emulator. Git status. Yes, new script and changes on the scene. Git add everything. Git commit and add unit test for PCC and PCS, closest 5. And let's push it. And our task should be done. Yep, now goes to the BCC and BCS opcodes. So can I edit it? Edit BCC and BCS opcodes. Save it. So let's go to the script. Let's go to the CPU and let's create the function. This is branch the carry clear, branch carry set. So our function will be branch if flag matches. So it will take a flag and how is it? Yeah. How was the flag class named? NES register flag, bit flag. So okay, that was it. Bit flag, and B is set, and this is a boolean. So what we want to do is getting the address, and for that we are getting the address using always the immediate. It's addressing mode immediate, and we get it from the program counter. Wait, give me a second. So address is what is already on the program counter. So program counter dot value var value is equals to memory address and let's see the code of the example to make sure we are doing the right thing. So yes, he's reading directly from the program counter, so that looks correct. So jump, let's call it jump instead of memory address, and we can directly add one, I guess. Wait a minute, because we have the wrapping add problem. Okay, so first we have to turn this jump into a negative. So if jump and this bit, which is the 8-bit, 1 2 3 4 5 6 7, so this means it is negative. So in this case, jump equals minus jump and we remove that bit. OVO 11145678. Okay, so we are making it a 64 bits negative because we don't have signed and unsigned math. So now we already have negative and positive jump value, and now we can add 1 to this relative value. Jump plus equals 1, which is for the access to this memory value. So in theory, we can now make run counter value equals split equals jump, and if this is a negative value, it will decrease instead of increase. And that is the other case that we did not test. We only tested positive jumps and not negative jumps. And I have no idea how to create a test case for that, so I will choose not to it. So now we can register the code. So before LDA, we can create BCC, BCS. Copy this, and let's see what was our opcode. Our opcode was 90 for carry clear. Okay. It was 90. It's not focused. For BCC, and it takes 2 bytes and 2 cycles, and it does, let's find the branch if flag matches. And we are going to pin the flag that we want to check, which is flags.carry. And if we want it to set or unset, in this case it is unset, so we pass false. And we duplicate this line, and we make branch if carry set, and we use B0 and change the unset for set. And let's pray to God that this works and try to run it. And it failed. So let's see why it failed. What is on register X? CPU register X, and the value is 0. So seems like it did not oh, I see. So it did read the value and added 1 and made the jump, and then added 1 again, because we're always adding 1. So maybe the solution is to not add 1 at all. So let's see that. Oh wait, no, because this is the jump. So it is going to add 1. After this. So I think remove this and let the program take care of itself, because we are setting the program counter, and when we jump from this byte by 2, 1, 2, it will stay here and then add 1 because of the number of bytes that it takes, and continue from here. Wait a second. here, do it to 1, 2, and then it will move this one. Okay, and continue from here. So let's give it a try, and now it passes. So yes, we did not need to add that +1. I don't know why it is different at his implementation. Maybe in his implementation it does not, it is not reading the bytes from the opcode. I don't know. We can try to make a check about that, because it's doing branch and it's making this. High, low, memory for CPU, get operand address, yeah, and then every function and where it's run. Add to register A, subtract, so if we search for the program counter, so in run it reads the memory, adds 1, it is making a copy of the program counter, then jump absolute heads directly the program counter, and jump indirect, make some stuff. So the point is, all of these are jumps. RTS is for the stack, RTI is for the stack, and program state equals, so if the program, so what this is checking is if the command did not modify the program counter, then then it makes the change from the opcode. I see. So that's why he adds that one. And this is maybe not a bad approach. Maybe I should do the same, so I can have more. I don't have to be concerned about the length of the instruction when making the jump. So yes, I can put this again, jump +1, and I will do the same as he did in here. So if it run, yes. So opcode is an integer. Bar current PC equals program counter value, and then if current PC equals program counter dot value, that means it has not changed it internally, then we change it from here. It makes sense. So there was not a jump. Okay, So let's confirm this still works, and it still works indeed. So I think we can just commit it, right? Status, only one file changed, it add part. So we registered the new opcode, changed it so the jump is happening here, and we made a new function for the jump, and we did not change the test. So, git commit message implement bcc and bcs opcode closes. I think it is 6. Confirmation please. Yes, it's 6. Git push origin main, and this should be done now. Okay, getting a lot of progress here. So let's take a look to what is next and prepare the task for it. So what I am going to do is place this like this and like this, and let's see this list. So next is branch equal, I think. Unit test for DEQ, DEQ opcode, unit test for DIT, DIT opcode. Next is DMI, unit test for DMI. This is all very slow. DMI opcode, unit test for DNA, DNA opcode, unit test for what is it? DPL opcode. We kinda currently have PRK already, so I will skip it. Unit test for BBC. Right, so I think we already have this one because this is another flag. So I think this is branch if overflow is clear. Unit test, sorry. So I will edit this one. And put BBC, and I suppose there is a BB set. This is BBS. Oh, it was right after. I skipped it accidentally. Okay. BBC and BBS opcode, and this is LEI. So these are not clear or set. And that is the last of the branching methods. So I think this is what we are going to do next stream. And we are done for today. Thank you very much for watching, and see you next time.